clowns in the back here. All right? Everything okay? Okay, so we're live here. Good afternoon, everybody.
Good afternoon.
Yeah, great. All right. Okay, so P6 is complex numbers. First things first, I got a bunch of scattered thoughts on here because these are, the ideas that you should remember at least from last year. And I'll kind of identify the key components. This is a real lame set of numbers charts. Okay, if you remember, we did start this with P1. Very first thing we did was we put the real numbers. Okay, now I'm going to do some group responses if you remember. We started with the smallest set of numbers, which are counting numbers or natural numbers. 1, 2, 3, 4. Then the next one starts with a W. What's the next set of numbers bigger than natural numbers? Whole numbers is right. Group number 8 back there. One of the group members in there. All right, then after whole number starts with an I. And not imaginary, went too fast. That's not in the real sense. Integers. Then what's after integers? Starts with an R. Rational. And then what's the opposite of rational in a way? Irrational are those that cannot be expressed as a decimal or fraction. That's all real numbers. Well, then there is not real numbers, which are called imaginary numbers, which come from this. Square roots of negatives. Now, I have no tolerance for this. Yeah, I got this online. I've already said the reference. A dog has, anyone? 4 legs and what? And what's the whole point of that silly little statement? It is that some things just are. When you were a kid, you didn't know what a dog was until you started learning to speak, and then you had a dog, and then you said it, and there was nothing to understand. That's what it is. So right now, everybody say, I is the square root of -1. Now,
I is the square root of -1.
There is no I don't get it. There's a dog back there. There is just, that's what it is. Now, I will tell you kind of where it comes from. You can Google this. I don't really know, but I know that somebody back in the day said, all right, well, first of all, the problem is there is no answer for this. Square root of -4. What times itself equals -4? Well, not -2, because what's -2 times -2? 4. So there is not an answer for this question. So somebody back in the day said, all right, maybe we could break this up. So that's what I did next. I broke it up. We got rid of the square root of negative by calling it square root of -1 times the square root of 4. Now everyone knows what the square root of 4 is. What is it? 2. So then someone said, you know what? Since square root of -1, we're isolating it. Let's call it something. So what do they call it? I. Hey, I'm just the informant. This is what somebody did so that they can deal with these numbers and then proceed on and do other stuff with it. I will tell you that I numbers do have applications. I'm not saying I understand them. I'm not an electrical engineer, but I know I numbers have to do with electrical currents in some way, shape, or form. So there are applications to it, uses, and so on and so forth. Now, I will tell you that the word complex numbers, like I told you in P1, actually is both sets of numbers put together. I'll tell you a story about students I taught my first 3-4 years. I told them complex meant imaginary. I was wrong. I screwed up all those students. They're all ruined. All right? So understand complex means both real and imaginary if you want to play with the words there. Okay, so all this little thing that you're writing down or not this is the form of a complex number, A plus BI. And I'm going to ask you silly questions on easy questions about, what's the real part and what's the imaginary part. It's not really a big deal. And this is just silly to even show you. What's a variable? The word variable means changing. Okay, that's what variable actually means. So when we say X is a variable, it can change. It's a number for it's a place for a number. Is I really a variable now? Yes or no? No, I doesn't change. I is what? Say it. Square root of -1. By the way, this drives me nuts. It makes me want to jump out the window. Good thing we're on the first floor. When I ask you tomorrow, what's I, how many students are going to say -1? Now it's going to say something right now. Would you rather have $4 or the square root of $4? Why would you want $4? And basically there's a difference. So is there a difference between -1 and the square root of -1? You better darn well believe it. Okay, so make sure you understand that. But is I really like a variable? Actually, yes, it is. And I feel silly that we even have to cover the first two examples. But the first thing I will say, and I'm just going to shove this at you, and then we'll maybe pick some groups here that we can hear now, is this is not a foil. Actually, this is the book trying to be deceptive. The parentheses are absolutely, positively what? Starts with an M. Meaningless. Okay, you didn't know what M word I was meaning there. So what do we actually really do? Combine like terms. And yes, in this case, I works like X. So some of your homework you could have done without me. You know, I don't even remember what I is, but you could have just started looking at, oh, I know what to do. Just add like terms. And actually, in this first case, you would have been right. One of the biggest mistakes students do is not doing what with this? Distributing. And then we'll get some, start picking on some groups. Distributing. And then going from there. Minus 4i. Okay, going to take a break from the video for a second. Got to catch my breath. And I missed. Can you do anything with the square root of 5? I'll just tell you no. Can you do anything with the minus 3i? No. Can you do anything with negative 2 yet? Not quite. What's the square root of negative 9?
3.
3 what? 3 what? Remember, this is the square root of negative 1 times the square root of 9. So it's 3 what? 3i. Okay, so that's what you have to do. You replace the square root of negative 1 with that letter, so you don't have to look at it anymore. Like the person that decided to do this is so that we don't have to look at it anymore, so we can, proceed on and then deal with some like terms. Then next, can you do anything with the root 5 and negative 2 without a calculator? No, so that just becomes root 5 plus negative 2. And then what about the i's? Now I have a real hard question for you, but what about the i's? What happens with those? I'm going to write this like this to help your next friend. Now these silly little questions. All right, and I don't want you to overdo it. It's really not that hard, but it is weird. What is the a part of this number? Whoa. What is the real part of this number? Ow. Let me help you with that. What's the b part? I wrote this for you so they could see it. What's the b part of this number? All I'm asking you is identify the real and imaginary part just to demonstrate some vocab for this section. Adam, the A part is actually all this junk. If you were asked, what's the real part of this? Again, don't overdo this. This is just math vocab that I'm going through at the end here. All right, so don't faint over what I'm doing right now. But in the standard A plus BI form of a complex number, the A part is this root 5 plus negative 2. And then you don't have to write this, but the B part is 0 because we lose that imaginary part. Ain't no thing. Round. Root 7. Just going to tell you can't do anything with that. First person. What is I squared? Whoa! I'm going to make you think from last year. Oh gosh, he said. We'll say he said that in a public school. So we're going to break this down. Same student. What's root 2 times root 2? Just answer that question. We're going to build you to somewhere. Stop doing that, student from group 6 over here. What's root 2 times root 2? 2. What's root 7 times root 7?
7.
What's root negative 1 times root negative 1? Ooh. Don't multiply the negatives. Just do freedom. Nope. Freedom of a negative 1. You're not supposed to do a negative times a negative in this whole idea. So basically I built you up onto how you free things out of a radical. Root 2 times root 2 is the square root of 4. Square root of 4, of course, is 2. Freedom. Root 7 times root 7, 7. Root negative 1 times root negative 1. Negative 1. So what's I squared? No. I squared is root negative 1 times root negative 1, which is?
So it's I, root I, right.
It's just what, everybody? Negative 1. It's a free negative 1. So that's why I wrote that off to the side. You'll get it. That's fine. You got to remember this from last year, though. Then what am I supposed to do with that minus sign? Hurry up.
Change it for positive and then
Distribute it. Got it. And then you also, that was kind of easy. What about that root negative 81? 9i is right. And then you just got to figure that out, that it's root negative 1, times root 81, and then you break it down. And then the last, students, I'll ask you to simplify what you can. So you can't do that, but then what can you add together?
Plus -7.
Yeah, that's a nice way of, I'll say -7, you said plus negative, same thing.
Plus
Oops, sorry, I got a little pickup on the screen. And then the A part, not to, I'm overdoing it. The A part is that, the B part is that. And don't worry about that too much. So, what I hid from that student that I asked the tough question, what's I squared, was that right there. So again, this is where the students go, when I say, what's I, they say -1. And I say, get out. Because what's I? Square root of -1. But what's I squared? Say that. Free -1, if you want to put that little free in there. There's a big difference. Now, after covering this, which is right in the book, I will cover or go to a group. Okay, and then sorry that I didn't get that ready. Again, you could have started your homework. I could have been absent today. By the way, I might miss tomorrow. Could have been absent. I could have been absent today, and you just done your homework, and you would have done this just fine, and then added these like terms. But I is not a say it variable. I actually is the square root of -1. So the problem with it is I squared needs to be simplified to be -1, and then you have some more, a change of like terms. So take a look at that, and then I am going to go to a group. All right, so I'm making my next group be the pen. So tell me what to write next. We'll start with you. 10i squared. Next. Oh, I know. Isn't it scary? I love it. It activates the brain in a different way. 5i. Do the next one too. -6i. Sorry, I didn't do the 5i line. Distributing. And then last.
+3.
Actually.
Or -3, sorry.
And then you have to do a couple simplifications. This one's easy. That's just like terms. But what does this become?
10 times -1.
Which is?
-10.
-10. Good. Well said. And then what's this middle thing become?
-1i.
-1i, or you know what? I don't like the way I wrote that. So let's go back. Let's just say plus a -i, plus -3, then final answer. We'll just have you finish it off.
It is -13 plus -i.
All right, and then I'll make it -i, whatever. Doesn't matter either way. And then, of course, the A part is -13. The B part is -1. All right, well said. With you. What's the square root of -4? That's what you better do on this one first.
4i.
Ooh. Careful. What I?
2i.
2i. And then actually, should you distribute now or FOIL, some people say? Yes or no?
No.
Why?
Because
Now that you made that 2i, what can you do with those? What this set of parentheses is here. Just think of variables. Sometimes you have to go back and think of I as just a variable. What's 2i plus I?
2i plus I is 3i.
3i. And then
Oh, yeah.
this really isn't, this is reduced as far as what you have to multiply. What word would you use to describe what you do here? What words would you describe to get this done? Distribute. And what do you get?
18i minus 15i squared.
Okay, and then back to you. Hi. What's the final answer?
18i plus 15.
And I'll write 15 first, just to, and I wouldn't mark you wrong for this. I think that's being mean. But I'm putting it in A plus BI order. All right, and that's all I did. Okay, first things first, we're now we're gonna go down and break down I. All right, what's I? Say it. Square root of -1. Now we should be able to say, what's I squared? That's a free -1. And I cannot overemphasize the difference between the two. All right, but then what we're going to do is proceed on and do I to the third, I to the fourth, fifth, sixth, seventh, eighth, I to the 257th. And you should be able to get to the point where I to the 257th is just as easy as finding I to the 11th. Really, the big power isn't a big deal. Because I to the third is simple exponents, I squared times I. Hey everybody, what's I squared? -1. So this turns into -1 times I. And then, of course, I is the square root of -1. But you're never going to write it like this. The only reason I'm writing it like this, though, is because you need to understand those negatives cannot eliminate each other. You have a square root of a negative on the inside with a negative on the outside. This is the simplified answer, not using I as the label for square root of -1. You will never write this on a test, though, or a homework assignment. I just wanted to cover that real quick so you understand. And then what's I to the fourth? Well, Mr. Samuelus, I to the fourth is I squared times I squared. Hey, everybody, what's I squared? -1 still. What's -1 times -1? 1. And you can go to your calculator and actually type these things in. Now, I am scared showing you this because I could also show my 5th grader and my 3rd grader. Not that they're majorly smart, they're pretty good at school, but I could teach them the button push. I could show them that I could show them the carrot button, and they go, "Ooh, carrots, can I have a snack?" All right, but so here we go. I, for an 84, is down here by the period button. For an inspire, just listen, it's the pi button. When you hit the pi button, though, then a whole bunch of things come up. One of them is I. So find the pi button on the left side, and then we're going to carrot that. Oh, Dad, I love carrots. And then 4. So I could teach them to do that, and then they've done nothing. They have no idea what the letter I even means, and that's what I'm worried about. I get a lot of students that are button pushing screen copiers. So you should hopefully know how to do this without this, but I'm showing you this as a tool. All right. What about I to the 5th? Well, I to the 5th is I to the 4th times I. Hey, everybody. This is going to be tough, but what's I to the 4th? We just found out it's 1. 1 times I is 1I. So if you type that on your calculator, you should get the same. I to the 6th? Well, everybody, that's I to the 4th times I squared. What's I to the 4th that we just found out? 1. What's I squared, which everyone should know? This is 1 times -1, which is -1. That's why you get this when you type it on your calculator. All right? Now, anyone without the brand new 84 and without an Inspire, we all get the same error when we type I to the 7th on. And I like it because most people can't read this. Therefore, they can't be a button pushing screen copier. But I will explain it. First of all, what's the answer supposed to be? I'll break this down a couple ways. And again, students that don't understand what I'm doing don't like exponents. We've already taught exponents twice in here. Hey, everybody, what's I to the 4th? What's I to the 4th? You're killing me. We're live. They're going to think we're losing the students. What's I squared? So it's 1 times -1 times I. What does that end up becoming? -I. So that's what this rigmarole says. I'm going to teach this once because this number or something like this will come up on your calculator a lot, even the Inspires. Who knows what that number means? Raise your hand. What's -3e, -13 mean? At least tell me the notation. Okay, and he stole your thunder. Scientific notation. You know what this is? I'm going to annoy the heck out of you. This is actually a calculator issue. It is a calculator malfunction in a way. Maybe malfunction is too harsh of a word. A calculator imperfection in the formula it uses to do I to powers. That -3e, -13 is -0.12 zeros and then a 3. What is this essentially?
0.
That is 0 minus I, which is -I. You need to know that when that pops up, that actually is 0 and it's a calculator issue, not your issue. Okay? So it is -I, it's just hard to read. All right, what are all of these then? Well, I to the 8th is I to the 4th times I to the 4th. So what's I to the 4th times I to the 4th? 1 times 1. What do you think I to the 20th is? If it's I to the 4th raised to the 5th. Hey everybody, what's I to the 4th? What's 1 to the 5th power? All of these are 1. So basically you're trying to look for a power that is a multiple of 4. Because any power of a multiple of 4 on I ends up being 1. I to the 24th, I to the 28th, and so on and so on and so forth. So let's do this one. You know, ding-a-ling, see? It's all exciting. What's I to the 126th? It's either what or what. My people last year in Math 2 figured this out. What are my two possibilities? 1 or? Negative 1. It's not I or negative I because the power is even. But actually the multiple of 4 is 124 with an I squared left over. So what is the answer? 1 or negative 1? See, this is 1 is what I'm saying, and this is negative 1. And I got that so fast because 4 goes into 100, right? Doesn't 4 go into 100? Yes, has a delicious sucker over here. And then 4 goes into 24 as well. So 4 goes into 124. All right, so that's why I know this is negative 1, and that's something you should be aware of. All right, then really kind of the last thing that we're going to do formally is this. And then I'm just going to shove the rest of the notes in you that you have to do the quadratic formula correctly and be careful. All right, the word conjugate. Now I circled this as a symbol, but I don't think I'm going to hold you accountable for knowing that that symbol means conjugates. It's the only book I've ever seen use that as a symbol. You just need to be aware of what a conjugate is. So if a plus bi is an imaginary number, a complex number, then a minus bi is its conjugate. And then I'm actually just going to go ahead and force these notes on you here. I will tell you that you could type this on your graphing calculator, press enter, and it will give you what the simplified answer for that is, which will give you absolutely 0 credit on your test Tuesday. None. So if I don't see the work to do this, and get this taken care of, you're doomed. So no button pushing, screen copying, as far as that is concerned. Now I will do this wrong first. So this is wrong, but you should write this in your notes that this is the most common error. Now, let's pay attention to the directions. Write the complex number in standard form. Or it could just say simplify. And you need to know the idea to simplify is to get that radical out of the denominator, because that's what's going on. What's I? The square root of negative 1. Okay, so here's the wrong thing to do. This is what I see all the time. Just multiply top and bottom by I. So go ahead and do this wrong if you want good wrong notes. And then understand that this is a common error and I'll stay away from this. Because what you really did is just rotated where the I is. You've really just put an I next to the 3 now instead of second in the denominator. By the way, what's I squared? This is negative 1. What's minus a negative 1? So this is 3i plus 1. You've done nothing. Wrong, wrong, because that was wrong. What you really need to do is multiply by the, starts with the C and you just heard the word. What is the conjugate of 3 minus I? 3 plus I. And then this is why this works. This is why this gets rid of the radical slash I in the denominator. In the numerator we actually distribute. In the denominator we've got to be good at foiling. 3 times 3 is what, everybody? Let's do group response. 9. And then I would hope you do not write this. This is the whole value of the conjugate. But we'll write it for note purposes. I would hope you don't write this and don't write this. Because what happens to these two always? If you select the correct conjugate, those middle terms will always cancel. If you select the conjugate to multiply top and bottom by. By the way, what is this equal to? 1. I'm multiplying this fraction by 1. This is why this is a legal procedure. And then what's negative I times I? Negative I squared. So then you get 6 plus 2i over, cancel, cancel. What does this become? What does minus I squared become? Plus 1. Now, if you circle this answer, I'll mark you so wrong so quick your head will be spinning. Because what else can happen with 6 plus 2i all over 10? You can actually simplify. You can't simplify like this. We've talked about that a million times in here. Not a million, but like 10. So that's a lot still. But what you can do is divide everything by 2. So 3 plus I over 5. The real legal way to do this is to take out a 2 out of the top and then cancel with the 10. But many of us know that, and we can jump right to that. Okay? Now, I don't want to bore you. Too late, right? Fumble. Sorry, I missed that fumble. But what would I have to multiply top and bottom on this one, and then we won't finish it off? What would I have to multiply top and bottom by? 2 plus 3i. And then I'm not going to finish this because of time and because of purpose. You get the idea. What would happen in this one is you'd have 4 multiplications up at the top, and then 4 multiplications up at the bottom, or down at the bottom, and then you just go from there. So just be aware of that for that particular question. Okay, then last but not least, not that this shucks, I forgot about something. Hold on. Almost said a little stuff that I'm going to help you on these little weird questions. They made a mistake. I forgot about something. Sin. Do you know what that is? Sine. We're going to solve a trig equation right now. Watch. Sine of x equals that. Somebody tell me what x equals. What does x equal? What would x have to equal for this to be equal? 7. Isn't it simple? It's just a simple matching. You don't even have to know what the word sine means. You might even think this is a 5. 5in(x), 5in(7). Well, x must equal 7 because it's in the same spot. Being weird, but it's true. Sometimes math comes down to that. It's just you see it. Hey, what's this? What's LO6? I've never seen that, but what is that? You're going to solve a log equation right now. What's x equal? 12. Sometimes the math comes down to that. Hey, you're going to solve an exponential situation. You don't even have to know what e is right now. But that is something you're going to learn about later. What's x equal? 4. Just by simple matching. That's your hint on 22. I want somebody to figure out what x is and what y is. Raise your hand when you got it. Robert? Oh, now you're online. Or George or Frank or, What's x equal? 3. We'll go to you. I almost said your name too. And I actually know it. That's good. I'm learning names now. We're in week 4. All right. What's y? You are correct. Y equals -7. This is a simple a plus bi equals a plus bi matching question. Like I said, sine, log, and e to the power questions were before that. If 3 is in this position and x is over there, x must equal 3. If y is here and I see -7 in front of that I, yi, -7i, y must equal -7. Okay, now try that for 24. Ooh, you might have to do a little bit of extra stuff. Okay, so we did have a person get 7 for x already because they did do this. All right, this is just a mess a little bit more than the last question. But my issue and everyone's issue should be, there seems to be a floater in here. Seems to be something that's kind of bothering me that doesn't belong maybe on one of the sides. So that's why x equals 7. You're right. Because 7 is in that A position, so x equals 7. What do you think I should do, though? Something doesn't match, and I got to do something about it. So same person that got x actually said, hey, maybe we want to clean this up a little bit, do our share, and then maybe we could find out what y is. But it's still tough a little bit. Did you get -3.5?
Yeah.
No, did you get -3.5?
Well, that's what I'm saying. Like, you got rid of the 7 there and the 7 there, because that's
Okay, I got you. All right. Okay, I got you. I got you. I'm sorry for stealing your thunder. All right, so it is negative 3.5. And what happened for this? You just set these two equal. Negative 2y equals 7, and then you go from there. So this is weird. I don't want you to confuse this. This is unconventional for sure. This is not your standard, how do I solve an equation? Whatever I do to one side, I do to the other. It's not really what's happening. You're doing a lot of matching. Then as you put your stuff away, the rest of the homework talks about this, and I'm going to zoom it back so you can see all three of these questions and go up to the overhead here, whatever you call it, and talk about these three scenarios. So in the quadratic formula, there's something that's called the discriminant. How many people remember that word? Okay, I'm just going to go ahead and talk about what it is. You're not really using the discriminant. You're going to find the actual answers using the quadratic formula. What you should put down in your notes, though, are these three types of things that are actually occurring behind the scenes. Number one, x squared plus 2x plus 5. Look at the graph of it. What is this graph not doing? Not touching the x-axis. Lo and behold, look at the discriminant of the quadratic formula. That is just the square root part, the b squared minus 4ac. What kind of number is it? Negative. So what happens when you take the square root of a negative? You get what? What kind of solutions? You said it imaginary. When you get imaginary solutions, the graph actually does not cross the x-axis. And that's something you did discover last year a little bit, but maybe not too in depth. What happens when the discriminant is 0? Well, what will happen when you actually find the answers or the solutions using the quadratic formula, you're going to only get 1. Because after the plus minus part, there's plus minus 0, which doesn't create 2 answers. It only gets 1. When you look at your graph, it only crosses the graph 1 time. It's actually said to be, let's play a little Wheel of Fortune here. T to the x-axis, TA, TAN to the x-axis, tangent. That's actually true. When a graph actually touches and then stays above like this graph does, that's said to be tangent, just touching. That's a geometry word as well. Then the more common things that occur, if I have a discriminant or square root of a positive number, then you get 2 unique answers. All right, and they're said to be real. But basically, in your homework at the end is you're just going to have quadratics that you're going to find the solutions for them, and you will get imaginary solutions.